Alright guys, welcome back, and we're now going to be looking at variation, our second to last topic, before we move into some mock papers. Now, variation simply speaks to the relationship between two variables. So for example, the connection between x and y, two variables, all we need to figure out is what is the connection between both. And the letters really doesn't matter. So whether it is x and y, a and b, c and d, it doesn't really matter, all right? Variation just speaks to the connection between one variable and the other. Letters don't really matter, all right? So we're just getting that. So right now, just having here that variation speaks to the relationship between one variable and another, all right? As far as variables concerned, let's just think of one letter as being a variable. So variation is a relationship between two variables. Okay, get that out of the way. Now, there are two types of variation. We have direct variation and inverse variation, and we're going to be looking at what each is actually saying. So there are two types of variation: direct variation and inverse variation. All right. Now, for direct variation, this is the formula that I want to look at. All right, y is equal to kx, and k is actually referred to as the constant of variation. So the two variables that relate to each other, y and x, and there's a k involved, and k is referred to as the constant of variation. So I'm just going to point this out here, that this k is the constant of variation. Okay, that's what k is, a constant of variation. All right, so this is the formula that we're going to be using to solve particular problems. Y is equal to kx if that problem is direct variation. What do we mean by direct variation? In direct variation, when one variable increases, the other variable increases. So if one variable goes up, then the other variable must go up as well. Or if one variable increases, the other variable must increase as well. All right. So in direct variation, when one variable increases, the other increases. And this word should be and, so there's a D missing there. So and when one decreases, that means when one variable decreases, the other variable also decreases. So when one variable goes down, the other goes down as well. So in summary, y is equal to kx. K is a constant of variation. So the two variables that are being referred to are, in this particular case, y and x. So if the value of y goes up, in direct variation, if the value of y goes up, then the value of x is also going to go up. Or if the value of y decreases, then the value of x is also going to decrease. This is a constant value in the grand scheme of things. You're going to understand what I mean shortly. All right, so that's direct variation for you. Now for inverse variation, this is the formula that I wanted to look at. Y is equal to k over x. Again, k is the constant of variation. So just pointing that out again, that k here is the constant of variation. Okay, and again, you're going to understand what that is meant in a little bit. So the two letters here, or the two variables y and x, are being related. And notice the difference in the formula now when we're dealing with inverse variation as opposed to direct variation. So this is the formula for direct variation: y equals k times x. But for inverse variation, it's y equal to k over x. Now, in inverse variation, when one variable increases now, the other decreases. So when one variable goes up, the other variable comes down. And when one variable decreases, the other variable increases. Inverse variation, all right? What does that mean? When the value of y increases, the value of x decreases. Or when the value of y decreases, the value of x increases. And again, K is a constant of variation. Now, here's a trick. You're going to be given a question and you have to figure out based on the question whether it is direct variation or inverse variation, because depending on which one it is, it's going to determine which formula that you use. Now, a question like this, we all know that we can work this out without even looking at the formula for variation, whether it is direct or inverse. Of course, we have to figure out which one it is. But we know we can work this out without even applying the relevant formula in variation. But we're actually going to use it to test to show that it makes sense. Now, all we have to do is figure out whether this is direct variation or inverse variation. So remember, with direct variation, the two variables have to increase together or decrease together. But in inverse variation, if one variable increases, the other decreases, or if one decreases, the other increases. So it says Jamaican $360 is required to purchase US $3. How much Jamaican dollars is needed to purchase US $7? Now the big question is this: is this direct variation or inverse variation? That is the big question. All right. So how do we work this question? Now, my argument is this: if you have more Jamaican dollars, would you be able to buy more US dollars? Yes or no? The answer to that is yes. So the more Jamaican dollars you have, the more US dollars you will be able to buy. And the less Jamaican dollars that you have, it means the less US dollars you will be able to purchase. Now, this is straight direct variation, because the more Jamaican you have, the more US you can buy. And the less Jamaican you have, the less US that you can buy. And for direct variation, the formula is y is equal to k times x. Now, there is no y and x in the question. There is a j and there is a us. So those are the two variables, j for Jamaican and us for American, or we can just say u for American. All right. Now, you have to modify this formula by using j equals, k always remains the same. So j for Jamaican and u for US, or guess what? If you do it the other way, as in put u first equals k times j, you can still work the question correctly. But I'm going to approach it this way first and then we interpret. All right. So this is for method 1 here. So j equals k times u. You don't have to stress yourself about whether you must put u here first or j, because you still can get the answer. It's just that the value of k might be different. All right. In this particular case, we're going to find out. All right. So we're going to approach this using method 1 first. So method 1. Now, we're using j equals k times u. J for Jamaican and u for US. Now, the first thing we want to do is assess this statement here. Right? So Jamaican 360 is required to purchase US $3. Remember, we said that it had to be direct variation, because the more Jamaican money you have that you take to the bank, is the more US that you can buy. And the less Jamaican that you have, the less US you can buy. So when one variable increases, the other must increase. And when one variable decreases, the other must increase. So it must be direct variation. It can't be inverse. It must be direct. So this is the form that we're using. And we can just adjust the letters. You don't have to be y and x, right? So method 1. So let's approach this now. So Jamaican 360 allows us to buy US 3. So how do we find k now? 360 divided by 3 equals k. And that's that. Now, what does this mean? Now, in this particular case, remember 360 here was for Jamaican and this was for US. Right? So, really and truly, if I had put this here, just for emphasis, we're breaking this down, right? So you can clearly understand what this k is saying based on this formula that we use. J equals k times u. Now, Jamaican was here because the 360 is Jamaican, and let's just use U for US here. So 120, even though 3 into 360 is 120, what it's saying is this. So it's saying 120 Jamaican per US dollar. So per 1 US dollar. So it means 120 Jamaican purchases 1 US dollar. That's what it means, simply because J is at the top and U is at the bottom here. So that's what this concept of variation means. 120 Jamaican per 1 US dollar. That's what it really means. And if you look at it carefully, you'll see that 120 Jamaican dollar will really purchase 1 Jamaican dollar. So that's the reasoning there. So what really and truly, the value of K is 120, and that's what we need to focus on. I'm just pointing this out in terms of the interpretation of what K really means. All right, so let's proceed now. So now that we know what K is, we can go ahead and focus on answering this part of the question. Very, very straightforward. So let's look at it now. How much Jamaican is needed to purchase US $7? So again, we're going to write the formula. So we'll finish with this part here. This part was all about finding what the value of K is, and we did. So let's write the formula again. All right. So we want to know how much Jamaican is needed. So this is unknown. K is 120 and the amount of US is 7. So we're simply doing a multiplication here. So 120 times 7, that looks like it's going to give us 840. So that would be 840. 70772 is 14 and 1, 840. So what that means is that it would take 840 Jamaican dollars to purchase 7 US dollars. And that's simply how we interpret this. So what we're going to be doing now is we're going to be looking at method 2 shortly, where I'm going to put U here and J here and then show you what that workout look like and what K means in that particular case. So you really don't have to be fretting yourself about whether you put U here or J here first. You're going to see it works out eventually. Just that K is going to have a different interpretation. So we're going to look at that next.